Hello. I've been losing sleep recently over something I've discovered in the world of mathematics. I've checked my reasoning as carefully as I can, but I simply can't make sense of the thing. So I thought I'd run it up the flagpole to see what you lot in the outside world made of it. It all involves infinite tetration. That's tetration that you see on the screen. A number, which I've called x here, being raised to the power of itself, raised to the power of itself, raised to the power of itself, and so on. If it's infinite tetration you're talking about, then the powers of x in this case go on literally forever. Now here's an equation involving infinite tetration. X raised to the power of itself infinitely equals 2. The question is, how do we solve this and find the value for x? Looks impossible, doesn't it? And indeed, this equation is often set as a brain teaser to see if people can think laterally. In fact, once you know the trick, it becomes simplicity itself. Consider all those powers, which I have enclosed in this large red box. What do those powers come to? Well, we know that. Those powers are x to the power of x to the power of x, etc., extending infinitely, which is identical to the original expression. The original expression comes to 2, so does that stack of powers. Basically, we can replace all those powers with the number 2, which leaves us with something that is trivially easy to solve. X squared comes to 2. X is plus or minus the square root of 2. See? Simple. And of course there's no reason why we should stop there. Let's replace 2 in that equation with 3. X raised to the power of itself infinitely comes to 3. What's x? Well, applying the same logic tells us that those powers must themselves be equal to 3. Take the powers out and put 3 in their place, and we see that x must be the cubed root of 3. The problem comes when we try the same thing with x equal to 4. You won't be surprised to hear that the solution to this equation is x equal to the 4th root of 4. Same logic as before. Here's the problem. There are 4 4th roots of 4, and 2 of them are plus and minus the square root of 2, the exact same values we worked out 2 problems ago. Indeed, if I check with my trusty old calculator that prefers positive real roots to numbers, it tells me that the square root of 2 and the 4th root of 4 are exactly the same thing. So when you put the square root of 2 in that expression, does it come out as 2 or 4? Now, we've all seen equations that have more than one possible solution. Quite early on in school, we came across quadratic equations like this, where you could put more than one value of x in one side and it would produce the same answer. But that's not what we're talking about here. No, here we put exactly the same value of x in exactly the same expression and get 2 different values out. Unless there's a fault in my logic, that is. The trouble is that sticking the square root of 2 in that tetration to see what happens just isn't an option. It's infinite. The only way of solving the equation is the way I showed you. I've looked at this problem from every angle I can think of, and I still can't make sense of it. One thing is obvious, though. There's clearly a flaw in my logic somewhere, but for the life of me, I can't put my finger on it. I appreciate that all the educated maths professors out there are watching this video, pointing their fingers at me and laughing. Good heavens, they're saying. We solved that old chestnut back when Pythagoras was in short togas. Well, if that is the case, won't one of you take pity on a poor idiot and explain in the comments what I'm doing wrong? And it gets worse. We've solved the equation when it's equal to 2 or 3 or 4. Mathematicians generally accept that the pattern continues. Put that stack of x's equal to 10, and x comes out as the 10th root of 10. Put it equal to 20, and the solution is the 20th root of 20, and so on. Bob, the slide's upside down, Bob. Sorry. Sorry about that, folks. The trouble is that these roots get smaller as the base number gets larger. I put a few of them on the screen here to 3 decimal places. You can see that the 5th root of 5 is small, but the 10th root of 10 is smaller, and the 20th root of 20 is even smaller than that. As the base number gets larger, the root gets closer and closer to 1. And yet the equation tells us that as x gets smaller, the result of the calculation gets larger. Reduce x from 1.380 to 1.259, and the result of that expression goes up from 5 to 10. Just as a double check, I tried limiting the number of powers to 4 and trying the effect of putting in different roots. As soon as the number of powers becomes finite, we can get an actual number out of the expression, and lo and behold, now it follows common sense. As the values of x get smaller, so do the calculated totals. But when the stack of powers is infinite, a smaller base number means a larger result. So there you are. If you can throw any light on the matter below in the comments, please do so.